Okay, so in this video I'm going to have a look at differentiating functions. I'm going to just do a lot of examples of different types of functions that you may be required to differentiate. So let's just start with basic ones. So I'm going to do y is equal to, I'm going to do the basic rule, y is equal to x to the power of n. Now the basic rule is just simply dy dx is equal to, you take the n here and bring it down here, multiply and then subtract 1 from the power. So what you end up with is n times x to the power of n minus 1. So if we take, for example, our y is equal to x cubed, then dy dx is equal to 3 times x squared. Bring the 3 down, subtract 1 from the power. Okay, so that's a basic example there. If we try, let's say y is equal to, let's say 3x squared, well then dy dx will be, what you need to do here is take the power, bring it down here, multiply by 3, so you get 6. And x, subtract 1 from the power, so it's 6x to the power of 1. Let's try another one. Let's say we have y is equal to 3x cubed plus 4. Well then dy dx will just be, bring the 3 down, multiply by 3, that'll give you 9. X, subtract 1 from the power here, so it'll be 9x squared. Plus, differentiate a constant, that'll just be 0, because 4 doesn't change with respect to x. So our answer here is just simply 9x squared. Okay, let's try one more. Let's say f of x or y here is equal to 6x cubed minus 9x plus 4. So here f prime x or dy dx is 3 6s 18 here. Bring the 3 down, multiply by 6. Write down the x, subtract 1 from the power, so we end up with 18x squared. Now do this one here. You do each term individually. So this term here will be, there's a 1 up here. Remember, bring that down, multiply by minus 9. You get minus 9. Then there'll be an x here, but it'll be to the power of 1 minus 1, which is 0. So here you'll end up with x to the power of 0, which is just 1. So really you'll just end up with minus 9 when you differentiate this term. And as with the previous example, if we differentiate a constant, we'll just get 0. So our answer here is 18x squared minus 9. Okay, so let's try another one. Let's say y is equal to, let's say the square root of x plus 8x minus 7. Okay, differentiate this, what do we get? Well, the only difference here is this term here. But if we look at that term, that's really just x to the power of a half. Here we have 8x still, we leave that as it is, and minus 7. So you do exactly the same thing again. Take that half, bring it down here. So we get half x, and then we must subtract 1 from a half. Subtract 1 from a half, you get minus half. Here we're just going to bring the 1 down, there's a 1 here, bring that down, multiply by 8. So we get plus 8, and as previously, we'll just get x to the power of 0 here, which is 1. So really here what we get is 1 over 2x to the power of a half plus 8. So that's just really 1 over 2 times root x plus 8. Okay, let's try another one. Now I'm just going to move on to the log of x. So let's say y is equal to, let's say the natural log of x. Our basic rule here is dy dx is equal to 1 over x. So for example, if we take, we'll use the chain rule here, log 3x, let's say, is equal to y, then dy dx here. Now this is our basic example, this is our basic rule here for log. So now we don't have x here, we've got a 3x, so we've got to apply the chain rule here, because really we have a function of a function here. Now there's a couple of ways of doing this, but the quick way here is just to differentiate it as if this was just just x, if you like. So that really what we would get here is just 1 over 3x if we just apply this rule directly to this term here, log 3x. dy dx will be 1 over 3x. However, because this is not an x, it's actually 3x, we must differentiate this part as well. So if we differentiate this part here, we get 3. So really our dy dx in this particular case is 3 over 3x, or just simply 1 over x. Now let's try another one with log. Let's take y is equal to log, let's say 3x plus 5. Okay, well again here we apply the rule, this rule here directly first of all. So dy dx is equal to 1 over the bracket, 1 over what's in the bracket here, 3x plus 5. And then we must differentiate what's inside the bracket here. And in this case, if we differentiate what's inside the bracket here, here we'll just get 3, here we get 0. So we just times this by 3, so our answer here will just be 3 over 3x plus 5. Okay, so let's try another one. This time I'm going to move on to our exponential function. So I'm going to take y is equal to e to the power of x. Here our basic rule is dy dx is equal to e to the power of x. It actually doesn't change. It's one of these functions where if you differentiate the function, you actually get the y value. So the slope, I mean, if we take the differential function here, it looks something like this. Okay, and if you take, say, our x-axis here and y-axis, if you take a tangent here at any point x, if you take a tangent here at any point x, so this x value down here, if you differentiate, this is y is equal to e to the power of x now. So if you differentiate this function here at this point here, it'll give you the slope at the slope of the tangent at this particular point, and it actually turns out to be this value here, this y value here. So in other words, dy dx is just simply e to the power of x again. Okay, so let's just have a look at one or two functions with e to the power of x in them. Well, let's just take okay, so let's take y is equal to e to the power of 3x. Well, here our dy dx is equal to, we've got to use the chain rule again here. This is not e to the power of x, it's e to the power of 3x. So we apply this rule directly first, as if this was just x. So we just write down e to the power of 3x first of all. So that's applying this rule directly without changing this 3x. Next thing we must do, because this is not an x, it's a 3x, we must differentiate this 3x here, and that will just give us 3. So our answer here is just 3e to the power of 3x. Okay, let's try another one. Let's say y is equal to 5 times e to the power of, let's say, 4x plus 1, and let's even square that. Okay, so let's see, we've got y is equal to 5 times e to the power of 4x plus 1 all squared. Let's do all of that. Well, it's not e to the power of x, we've got various things attached to it. So let's see, we have dy dx anyway. Dy dx is equal to, well, you just apply the rule directly first of all. So we're just going to write down 5e to the power of 4x plus 1 squared first of all. Now what are we going to multiply that by? Well, we've got to multiply it by the differential of this thing here. This is 4x plus 1 squared. So we have 4x plus 1 all squared. So we've got to differentiate this and write our answer down here. So how do we differentiate this? Well, we use the chain rule again here. So I'm going to take this 2, bring it down here, write down the bracket. So we get 2 times 4x plus 1. Then subtract 1 from the power, we get 1 here. Now we must differentiate what's inside the bracket. So when we differentiate what's inside the bracket here, we get 4. So actually what we get here is 8 times 4x plus 1. 2 times 4 here will give me the 8. So really what I'm going to multiply this by is I'm going to multiply this by 8 times 4x plus 1. So my final answer here will be 5/8 40 e to the power of 4x plus 1 squared, and then that's multiplied by 4x plus 1. So quite a big answer here. Okay, so that's that one. Now let's take another type of function. Let's take y is equal to well, it's actually y is equal to a to the power of x. Y is equal to some number here to the power of x. Well, our rule here is dy dx is equal to the a to the power of x and then natural log of a. So let's try one of those. So this is our basic rule. Okay, so y is equal to a to the power of x. So let's take, I don't know, y is equal to, let's take 2 to the power of x. Okay, so dy dx then. dy dx is equal to, well, our 2 here is our a. So it's going to be 2 to the power of x and then log 2. So this is our answer here. This is our differential here. Okay, let's take y is equal to 2 to the power of 3x. So now again we don't have an x here, we have a 3x, so we're going to have to apply the chain rule here. So first of all, apply the rule directly, this rule here directly, so it's dy dx is equal to, well, our a is 2 and then we've got to get log of 3x. No, sorry, we've got to get the log of, so it's a to the power of x. Sorry, I'll just start that again. Okay, let me start that again. So first of all, our a is 2. Our a is 2. So we've got to write down 2 to the power of our x here. Our x here in this case is 3x. And then we've got to get the log of 2. Now because this wasn't an x here, it was actually 3x, we've got to differentiate this part here. So we've got to multiply all of this by 3. When you differentiate 3x, you get 3. So this is our answer here. Okay, so let's move on to some trig functions then, trigonometric functions. So let's take, first of all, y is equal to, we'll take sine x. We'll take y is equal to cosine x, and we'll take y is equal to tan of x. Now if we differentiate each of these, dy dx here is going to be equal to, if you differentiate sine of x, you get cosine of x. If you differentiate cosine of x, you get minus sine of x. And if you differentiate tan of x, you get sec squared of x. Remember, sec is just 1 over cos, so it's 1 over cos all squared. But these are our basic rules. Now I'm not really explaining where these come from, I'm just giving you the actual rules and not really going into the explanation as to where they come from. We can do that some other time, but let's just apply them anyway. So if, for example, let's say here I've got y is equal to, let's say, sine 3x. Okay, again, we're going to apply the basic rule here, first of all. So we want dy dx is equal to cosine 3x. So that's applying the basic rule. However, this is not x, it's 3x, so we got to apply the chain rule and differentiate this part here. And if we differentiate 3x, we get 3. So I got to multiply by 3. So this is my answer here. Similarly with the other ones here, let's say we have y is equal to cosine 5x. So then dy dx here will be equal to, first apply the rule directly. So it's going to be minus, and then it's going to be sine 5x. However, because this is not x, it's 5x, we've got to differentiate the 5x, so that will give me 5, so I put 5 in here. Similarly here, if we have y is equal to tan, let's say we'll just do a basic, we'll do tan 3x, we'll do the same again. So again, this is dy dx here, and here we get sec squared 3x. and again you must differentiate this part here, so that will give me 3. Okay, so let's just look at one or two more of these. Let's say, for example, I had y is equal to cosine, and let's square it, and we'll take 2x. So this really is just equal to, this is the way we write cos of something squared. So in other words, the way we could write it is like this. It's just cos of 2x all squared. So we're going to have to use the chain rule here twice actually, but so first thing we got to do is we write down dy dx anyway, and this is similar to our very first rule. It's something squared. How do you do that? Well, you take the 2 and you bring it down here and multiply. So we're going to write down 2, then we're going to write down our bracket here, which is cosine 2x. Then we're going to subtract 1 from the 2, so we get 1 up here. Now I must differentiate, because it's not x squared, it's cos of 2x squared, I must differentiate what's inside the bracket here. So how do I do that? Well, cosine, if I differentiate cos of anything, I'll get minus sine of the 2x. However, it's not cos of x, it's cos of 2x, so now I got to differentiate this bit here. So if I differentiate 2x, I'll get 2. So there's the chain rule is applied a couple of times there. So actually what I end up with here is, let's see, 2 2's 4, and I have this minus here, so I'm going to put all that out front, so it's minus 4. And I've got cosine 2x, and then I've got sine 2x. Okay, so that's just applying the chain rule a couple of times. Okay, now I'm going to look at some inverse functions, and I'm going to look at these 3 here. I'll write down the rules first. Again, I'm not going to go into where they come from, that's a separate video, but I will look at just applying the rules. So the first inverse function I'm going to look at is sine inverse. So I'm going to take sine inverse x over a, and that's equal to y. Second one I'm going to look at is cosine inverse x over a, and the third one is going to be tan inverse x over a, and that's equal to y here. So what do we get if we differentiate these? Well, in our first case this is sine inverse here, so that's going to be 1 over the square root of, now this is, remember, is dy dx, the square root of the a squared, so whatever's on the bottom here we're going to square that, so it's a squared, and then it's minus the x squared on top here. So that's our rule here. Here we're going to end up with, this is cosine, so that's going to be minus, and then it's 1 over, again it's the square root of a squared minus x squared. Okay, so the only difference between these two is the plus, one is minus. The sine is plus and the cosine one is negative. Now what about tan then? Well, tan then is just going to be, again this is dy dx here, by the way, dy dx. So tan then is going to be a over a squared plus x squared, and that's our dy dx. So there are 3 rules, so let's just have a look at 1 or 2 of those. So let's take sine inverse first. Let's take that one. So let's take y is equal to sine inverse, let's say square root of x. Square root of x here. So now I'm going to do this one 2 different ways. I'm just going to do it directly, and then I'm going to use kind of more formal chain rule method of doing it. So let's have a look. Okay, so I'm just going to write this, by the way, as sine inverse, and it's x to the power of a half. The square root here is just x to the power of a half. So okay, so let's see, dy dx here, dy dx is equal to, well, let's just apply the rule first of all. I'll just bring the rule down here. It's this one here. So it's going to be 1 over square root Now it's going to be our a squared. Now in this case our a here is 1. All of this is over 1 if you like. Yeah. So our a squared is going to be 1, and 1 squared is 1, and then it's minus whatever's on the top here. Here it's, with our rule it was x on the top, so it's x squared. Here we got an x to the power of a half, so it's not x, so it's x to the power of a half, and then we've got to square that. Now because this wasn't an x, it was x to the power of a half, we've got to use the chain rule, so I've got to multiply this by what I get when I differentiate this bit here. So I've got to differentiate the x bit. So let's do that. Well, to differentiate that, we've seen that earlier, bring the half down, multiply it by x, and then subtract 1 from the power, so that's minus half. So if I do all of that out, I end up with 1 over, so on the bottom here I've got square root of, now here we've got 1 minus, now this is x to the power of a half squared, so 2 halves is 1, so I just end up with x there. Now I've got this half here, so that'll bring a 2 down here anyway. And then I've got x to the power of minus a half. Well, x to the power of minus a half is 1 over x to the power of a half. So I've got a 1 over x to the power of a half, or just square root of x. This is our x to the power of a half here. Okay, so that's one way of doing it, and let me just show you another way of doing it. Kind of going to run out of room here, but so I'm just going to end up doing one of these, but let's see. Okay, so if we take our y is equal to sine inverse x to the power of a half. Well, let's do this by substitution. So what I'm going to do is take u is equal to x to the power of a half. So that will give me du dx is equal to a half x to the power of minus a half. Now if u is equal to x to the power of a half, that will give me y is equal to sine inverse u. I'm replacing the x to the power of a half here with u. That will give me dy du is equal to, now this is, I can apply the rule directly here. I have a u over 1, so I don't have to worry about a chain rule for this particular part here. So what I can do here is just simply write down the basic rule here. So this is sine inverse u, so this is going to be 1 over, and then it's going to be the square root of, a here is 1, so that's going to be 1 squared, minus the u squared here. Now if you remember, the chain rule is just dy dx is equal to dy du times du dx. I did this in a previous video. So this is your chain rule here. So if I just stick in the dy du and the du dx, I've already worked those out here. See what I get. Let's see, dy over dx here is equal to, well, dy du, we've done that here, dy du, that's 1 over square root of 1 minus u squared. So that's the dy du part, that's this bit here. I've got to multiply that by du dx. Well, du dx is this bit here, so that's half x to the power of minus half. Okay, so let me just write out the final bit then here. I'll do it in white. So it's dy dx is equal to, I've got 1's on the top. I've got a 1 on the top here, a 1 on the top here. X power of minus a half again is 1 over root x, or 1 over x to the power of plus a half. That's this bit here. Okay, so let's just write all that down. So it's dy dx is equal to 1 on the top, all over square root 1 minus u squared. Well, u is just x to the power of a half. So instead of this u here, I'm going to resubstitute back in my x. So it's 1 minus the x to the power of a half. And remember, we're squaring it here as well. We're squaring it. So in fact, if I square that, I'll just end up with x to the power of a half times 2, which is 1. So here, this will just be x. So I'll just put that in because I'm kind of running out of room here. So really I just end up with x here. It's x to the power of a half squared, which is just x. Now I've got this 2 on the bottom, so I've got to put a 2 down here. And I've also got this x to the power of minus half, which is the square root of x here as well. So you can see here I ended up with the same thing, doing it two different ways. Now I've kind of run out of room here, so I can't really do the other two, the sine, the cosine and the tan, but they're exactly the same, the exact same kind of procedure that you can apply to those two.